Hello guys, we're in part 3 of this real number analysis. My name is Ejida. They want to discuss a rational number. Now it's getting broader or it's getting more complex, but we'll try and simplify it for us to understand. Now, what is a rational number? If I take a set, it's defined as the set, let's say Q, which is a what? Subset of A over B. Now A over B, where A comma B is an element of Z, where B is not equal to what? 0. Now this what we are saying is that if you have a fraction A divided by B and B is equal to 0, it makes this particular function as numbers undefined. Now, and when it's undefined, you cannot analyze that what any number at all, but it now becomes a complex number. Now, we must also ensure that okay, B can be 1. If it's 1, A become a positive integer. If B is minus 1, it becomes a negative integer, which is non-negative number. And also, if B is now, let's say 2 over 5, maybe A and B is 2 over 5, it becomes either terminating. And don't forget, all integers have whole number called 1 under. So that is to say, rational numbers are numbers that what at terminates or what reoccur. So we say they are what reoccurring number or terminating numbers. So how e.g. let's say we take what 2 over 5. 2 over 5 is 0.4. This is a terminating number. Let's say 1 over 3 is 0.33333 like that, and so forth and so on. You can have what 2 is what a rational number, minus 5 over 1 equal to minus 5. It's a rational number. So etc. So any number that reoccur, when we say reoccur, it repeating itself, we say this what is a rational number. But anyone that terminates is what? For example, 1 over 4 is simply as what 0.25, which is what it terminates. But if I have 1 over 6, for instance, it's about 0.1, 0.1 there, 6 like that. Because if you add, okay, let me see, you have what 0, then add 0, then 4, 40, then you have 6. That's what I want to have. Okay, it will be recurring, and you know that these are examples of that. What about square root of 2? Square root of 2 is an irrational number, so you cannot have it as rational. Now let's go on. Now, what are the closure property of a rational number? Now, a rational number, let's say A operate B to give us C. Now, don't forget that rational number, I told you, is a superset of integers and natural numbers. Integers are what natural numbers are under integers. They are what superset of integers and non-integers. So please take on that one. They are superset of what? Integers and non-integers. So what we say, if A operate B to give us C, what operation will this be for the rational number to be closed? I gave you a shortcut here, which is sum. It means we are going to have what? Subtraction, addition, and what? Multiplication. So this is the what operation that will make a what this particular one to be a closure. That will make a rational number exist as a closure property. I told you that a closure property is a property in which two operate each other to give the third, where all the elements got involved are set of the what of the rational number. So that was like just like when you have what 2/5 times 1/4. Now this one is a rational number. This is a rational number. If you multiply now, you're going to have what 2/20, which is shaped as what 1/10, 0.1. I mean 0.1 is the result of 2 divided by 2/5 times 1/3. This rational number, this rational number, this rational number. So that is a closure property under multiplication. If you see do division, the same thing. Do multiplication, the same thing. Do division. I think division now, why it will work is also what closure under division, but there is a but there. Why we don't put division most of the time is because there is a but there. Somebody can say, Mr. Alide, what about division? Let's say we have 2/3 divided by 1/4. Yes, it's close. But if the denominator is equal to 0, then it will not be close. It is what? Close for all division, except that the denominator must not be equal to 0. Please take note of that. Very important. I did not put it because I know subtraction, addition, multiplication can be closed for any condition. But for this one, division is not closed for all conditions. So if you see it in the exam, they put division. Yes, it's close. It's close. I did not put it actually. So you can see put division conditionally. Conditionally. Please put that division conditionally. Understand that word with a condition. So I believe I'll be able to explain, because most of the times what we know is that natural number, don't forget, is equal to is subset of what? Of integer, which we have what we know from class 1, class 2, and also what? Subset of what? Rational number. So natural number, subset of integer is subset of what? Rational number. Don't forget this. All integers are rational number, but not all rational numbers are integer. All natural numbers are rational number, but not all rational number are natural numbers. All natural numbers are rational number, but not all rational numbers are natural number. All integers are rational number, but not all rational number are integers. Look at the rational number. Integer is a part of it. The other one is not an integer. So what do you say about that? So you can see that it's very clear. Thank you. God bless you.